Welcome back, Chemistry 30. This is part 2 of the booklet 19.1, Acids and Bases. So now we looked at some general ideas of what acids and bases are. Now we'll look at more concise definitions. The first one deals with the Arrhenius definition made by Svante Arrhenius. So this one's very similar to how we described acids and bases previously. Acids ionize or dissociate or break down to produce H plus ions, whereas bases ionize to produce OH minus ions. Okay, so very easy. Once again, an acid, it's a compound that begins with an H, so you can easily identify that, whereas a base is a compound that ends with an OH group. So you can take a look here. Obviously that has to be an acid because it begins with H. OH has to be a base, OH, and then begins with an H, so acid. So very, very easy. But of course there's a shortcoming to that because some acids and bases can't be described in terms of something that gives up H pluses or something that gives up OH minus ions. Okay, so the next definition is the Bronsted-Lowry one. Now for this one, it has a really good analogy in the textbook, and it deals with using a hacky sack or foot bag. So if we imagine the hacky sack or foot bag as being an H ion, whoever tosses the bag to someone else, that's considered the acid donor, and the other one is the acceptor of the H plus. So we'll describe things in terms of H plus donor and H plus acceptor. So if we take a look here, I just have a hypothetical acid here, HX, combined with H2O, yielding H3O plus and X minus. So what we do here is we look at pairing a reactant with a very similar product. And here I have, you know what to pair because they differ by a single hydrogen. So HX and X, well, they're almost the same except one has no hydrogen here, so we compare that. H2O and H3O, they differ by a single hydrogen, otherwise they're identical, so we'll look at that. So when looking at this, HX, the reactant acid HX, it loses an X. So think of this as a reaction before and after. Before it had HX, after it became X. So in other words, it must have gave up an H. It donated an H to somewhere else. Therefore, we say that that is the Bronsted-Lowry acid, or BL acid, because it donated an H. It's like it tossed a foot bag over to someone else. Whereas here, H2O becoming H3O, it must have accepted an H. It received an H, because how else did it go from H2O to H3O? So we call that the BL base, the Bronsted-Lowry base. Okay? Now on the right-hand side here, if we go in reverse order, H3O before becomes H2O after, so it lost an H, it donated an H, so it's behaving like an acid, so we call it the conjugate acid. Conjugate meaning paired up with. And X, if we're going from right to left, X became HX, it received an H, so it behaved like a base. It accepted an H, so it's the conjugate base. So reactants on the left-hand side here we refer to as BL acids or bases, and on the right-hand side, if we're going in reverse, conjugate acids and conjugate base. So if we take a look here, thinking about that, how do we define these? A conjugate acid is produced when a base accepts a hydrogen, or we can think about it in backwards. It behaves like an acid when going in the reverse reaction. So I have two ways of kind of describing that. Whereas conjugate base is something that results when an acid donates a hydrogen, it becomes the conjugate base. Or you can say in reverse reaction, it behaves like a base. Okay, so all of those are the same. And of course the pairing that I did here, pairing this HX with this X, pairing these two together, I paired them because they differed by just a hydrogen ion. So two substances that differ from each other by simply an H ion being added or an H ion being taken away. Amphoteric is a substance that can act as an acid or base depending upon the circumstance. So for example, believe it or not, water can act as an acid or a base depending upon what it's with. Okay, number 10 involves labeling like this and figuring out what the BL acid, the BL base is, and the conjugate acid and conjugate base is. So what I'll do is I'll get you to pause the video right now and see if you can label that. I kind of showed a hint of it there, but I'll get you to do that right now. Okay, so if we had time to do that, the first one here, HNO2, H2O, NO2, H3O. So if we look at nitrogen here, HNO2, NO2. So we'd pair those two up with each other, and H2O and H3O, we'd pair those up because they only differ by a single hydrogen. So when NO2 before turns into NO2 after, you can see it lost an H. It donated an H somewhere else. So it's the BL acid. And if I was going in reverse, it would be behaving as a base because it receives an H to become HNO2. So you can see an acid is always paired up with a base and vice versa. H2O becoming H3O, it received an H, it accepted an H, so it is a Bronston-Lowry base. Going in reverse, H3O becomes H2O, so it loses an H, so it's behaving like an acid. So paired up acid, we refer to that as conjugate acid. The last one here, C2H3O2 is paired up with C2H3O2. So we can see going from left to right, we lost an H. So it behaves like an acid because to go from before to after, it lost it. It donated an H like an acid. Going in reverse, receives an H to become H2C3O2. So it behaves like a conjugate base. H2O, H3O, H2O must receive an H to become H3O. So receiving, you're like a base. Going in reverse, H3O to become H2O, loses an acid, so loses an H plus, so it's a conjugate acid. There we go. Lastly, we'll look at monoprotic and polyprotic. The prefix mono means one, so one, an acid that only has one hydrogen, whereas poly, the prefix poly means many, so an acid that contains many ionizable H plus ions. So what the next question deals with is just showing the ionization of an acid as it gives up an H. So if we take a look here, carbonic acid, H2CO3, it has two H's, so it's a polyprotic acid, it has two H's. So if we imagine that H, it's an acid, so it gives up the H, the water takes on that extra H to become that, just like previously. H2O loses an electron to accept the extra H, so it becomes positive due to losing one negative. And H2CO3 becomes HCO3. Now it lost an H, it has an empty spot where that H's electron was, so it accepts an electron from somewhere else and becomes a negative one charge. So the empty space due to lost electron, it is the empty space that was lost, the empty space that occurs due to the lost electron is now occupied by a new electron, so it becomes negative. So this is called the first ionization, the first breaking down of the acid. So of course HCO3 minus has another hydrogen it can give up, so it does that, gives it up to the water molecule. Water molecule becomes H3O plus, and of course that has an empty spot again where that H was, so when we lose that H, the CO3 minus, it takes another electron, so it becomes one more negative, two negative. So think of it as going down the integer scale in the negative direction. So H3O plus and CO3 2 minus, that's called the second ionization. So there you have it. So polyprotic acid has more than one H that it can give up. it goes through, we can imagine it a series of a couple of steps here. Okay, we'll come back on a third video and discuss the vocab, so hopefully we see you soon.